this assessment, we're asked to sketch the C13 NMR spectrum for the molecule shown. Now, when we're looking at C13, we're not concerned with exact numbers, but ranges. And so as we go through, your answers might vary a little bit. We'll pick some number within the range, and we will draw the signal there. Let's start by looking at the carbonyl carbon, so the carbon of the aldehyde. This is usually going to show up around 200, so approximately 200. That's going to be the range for the carbon-oxygen double bond, specifically of aldehydes and ketones. The next carbon over here, this is a carbon that's attached. It's not part of a double bond, so not an alkene, not an alkyne. It's not attached to any electronegative atoms directly. These are going to show up in the range of 0 to 50. Because it's right next to the carbonyl, and we know we're going to need some space, let's go ahead and assume that that one is around 48 parts per million. The next carbon over here is next door to the alkyne, which might de-shield it a little bit. We'll say that it is around 45, let's say. Still in that 0 to 50 range because it's not attached to any electronegative atoms, double or triple bonds directly. The next two carbons are both part of the alkyne, so they're sp hybridized carbons. That's going to suggest that those might be around 70. So just so we have two different ones, we'll call it 72 and let's say 75. Again, we want to draw them in different places. The next carbon is just that normal aliphatic sp3 hybridized. We'll say that it's around 20. And then the methyl group, I'm sorry, we'll say that, let's change that. We're going to need this one to be around 20. We'll say that this one's around 35, let's say. Maybe it feels the alkyne a little bit. The methyl groups here, we'll say that those are around 20. Now, by the way, this same molecule, I think this was the topic of a previous assessment. If these numbers match the ones that Adam did in that video, fine, use those. The exact numbers aren't what really matters, just that we're getting them in the range, and that's really how we'll use C13. Well, with these numbers, we're now able to draw. We're going to have 1, 2, 3, 4, 5, 6, 7 signals. We have a signal at 200. We'll just draw out a straight line. The next thing we're going to come to is going to be around 75 and 72. We'll keep going down. We have, let's get below 50 so that we can do 48, 45, 35. Again, scale's a little bit off, and then we'll say that that is 20. So 1, 2, 3, 4, 5, 6, 7 signals for 1, 2, 3, 4, 5, 6, 7 equivalent carbons. Notice that I've drawn all of them being the same size. We don't get much information about the integration of C13, so we would expect them all to be similarly sized. We don't have neighbors, so they're all going to show up, or we run C13 in a decoupled mode, which causes all of the signals to show up as singlets, so we've drawn all of them as singlets. This is a spectrum that would approximate what we would expect to see taking a C13 NMR of this molecule.